Hello, and welcome back. Thank you for making your way to the Dimension Change podcast. Episode 2 is the very special Pi Day 2026 episode, released in the weeks after March 14th or 3/14/2026. First of all, it is entirely fitting to focus on pi because it was consideration of the nature of pi that unlocked all of the knowledge of the new model for dimensions. Pi is at the core of the path of exploration of dimensions that I followed. So I hope that by showing you the path I followed, you too can come to the same understandings, since they turn out to be objective mathematical truth that anyone can confirm now that I have pointed them out. The important thing is that at each point along the way, I will provide mathematical proof, not just speculation. For this Pi Day episode, let's start by proving some things I said in the first episode that are related to pi, but you didn't know it. I said that you've been living in a deconstruction, a literal world built based on a half unit, a half world, if you will. It's time to explain what I meant by that, since it is based on pi. In my research, I used a one-based system called mass spectrometry. It uses signal plotted on a scale of 0 to 100%. If you Google mass spectrum, it will confirm that a mass spectrum is based on percent relative abundance and has two rules. No value can be greater than 100%, and one value must be 100%, called the base peak. Other peaks are scaled relative to the base peak. Therefore, in mass spectrometry, it is important to always identify and know which value is the 100%, the base peak. Now, since the word percent means per hundred, 100% is 100 per 100, or as a simple ratio, 100% is 1. So we've seen how important the unit is in mass spectrometry. Now it's time to introduce the simulacrum and to see how it applies to units related to pi. In 2005 to 2016, I published a series of 4 papers beginning with the bottom-up solution to the triacylglycerol lipidome, leading to the simulacrum system as a construct for mass spectrometry of triacylglycerols and others. The simulacrum is a new, peer-reviewed, and proven equality that is a function that expresses the sum of two values as a value and a ratio. Here is a citation in the journal Lipids. A simulacrum is useful anytime a ratio provides information better than raw values. For instance, if your car dashboard only reported the value of the distance you have traveled, for instance 90 miles, you'd say, thanks, but that's not the information I need. I need to know how fast I'm going so I know if I'm under the speed limit. So the car gives you the time you've been traveling, such as an hour and a half. You say, that's not how this works. That's not how any of this works. I need to know how fast I'm going. Neither of those two raw numbers at face value would directly provide the desired information of speed or rate of travel. The ratio of distance 90 miles to time 1.5 hours is the speed of 60 miles per hour. This is the desired information. The ratio that provides the desired information is called a critical ratio. A critical ratio allows you to extract desired information from a set of values, just as I did using ratios of signals from mass spectrometry to deduce structural information using critical ratios that provided information at face value. From the discussion so far, you can see the importance of the identity of the unit in many contexts. And you can see how a critical ratio provides information better than raw values. So now it is time to introduce you to the new mathematical function called the simulacrum system. This is the first general form of a simulacrum, which can just be called the simulacrum. It is a function that allows you to arrive at the sum of two values by every combination of one value and a ratio of the values. Let's look at the parts of a simulacrum. Every simulacrum starts with a simulacrum sum statement, such as the simulacrum sum of A and B equals sim sum AB equals the sum of A plus B equals. The second part of a simulacrum is the possibilities to observe, or pos to obs. There are always four possibilities to observe. You can observe A directly, or B directly, or the ratio A over B, or the ratio B over A. Next is the interpretation matrix. The interpretation matrix holds the meaning of the symbols used in the simulacrum. What is A? What is B? What is the relationship A to B versus B to A? Which is preferred? Unless otherwise stipulated, there are no specifications placed on A or B. They can be any written name, number, symbol, value, anything that you can write. Next, the simulacrum solutions come in two cases. Case 1, where A is less than or equal to B, and case 2, where A is greater than or equal to B. And each case has 4 solutions for a total of 8 solutions overall. The 4 case 1 solutions are identical in form to the case 2 solutions, but the answer differs based on whether A is less than or equal to B or A is greater than or equal to B. So that is the most generalized form of a simulacrum. It applies to any two names, numbers, symbols, etc. But there is another simulacrum that is also super important and applies to Pi Day. It comes from when we invoke the rule from mass spectrometry that one value must be 1. We make that first specification that one value is 1 to get the first specified form of a simulacrum, which is called the unit simulacrum. It has all the same parts as any simulacrum. It has the simulacrum sum statement, the 4 possibilities to observe, and it has the interpretation matrix. But now we have added the first specification to the interpretation matrix, making this the first specified form of a simulacrum. And case 1 is where A is less than or equal to 1. Case 2 is where A is greater than or equal to 1. Let's go back to our dash that only displayed in raw miles or in raw hours. If we make the simulacrum of miles and hours, we start with the simulacrum sum statement. Then there are the 4 possibilities to observe. Then there's the interpretation matrix that holds the meanings of the symbols, such as miles equals distance in English measurement, hours equal time in conventional units. The desired ratio is miles per hours. But even though the number is right, we can see that the units are really in hours, plural, instead of per unit hour, per single hour. So what we want to do is to specify that hours equals 1. So the ratio will be miles per unit hour. In the process, we construct the ratio we want, which provides the information desired in the units desired. Now what we can do is to simplify the solutions down to the two simplest solutions where ratio miles per hour is either less than 1 or greater than 1. So far, we have shown how a simulacrum constructs a critical ratio to provide desired information. We have seen the importance of identifying and specifying the unit. We need to cover one more brief topic before we get to pi. It is the meanings of increments and decrements, or deconstructions. If you start with 1, a unit, and use the identity property of division to divide by 1, then you have 1 equals 1 over 1. Now, if you add 1 to the numerator, you increment the numerator by 1 and increment the overall ratio by 1. An increment by 1 can be called the first increment. This is as simple as 1 plus 1 equals 2. On the other hand, if you add 1 to the denominator, you increment the denominator, but the overall ratio decreases or is decremented. The first increment in the denominator is the first decrement, or first deconstruction, such that 1 over 1 plus 1 equals 1/2. To reiterate, the ratio 1 over 2, or 1/2, is the first decrement of 1, or 1 over 1, also called the first deconstruction of 1. Now, as we get ready to discuss pi, it is important to recognize the most important decrement related to pi. If you make d over 1 and then increment the denominator, you get d over 2, which everyone knows is equal to r radius. Thus, the first decrement, or first deconstruction of diameter d, is radius r. And it turns out that the simple act of a unit deconstruction, if nested and repeated, gives the Fibonacci ratios that converge at 1 over the phi ratio. 1 plus the nested decrements is the phi ratio. It gives what is called a continued fraction, and I found that William Jones had investigated continued fractions in the 1700s. When I saw that the 3-level deep simulacrum system for triacylglycerols had reproduced the first 3 Fibonacci ratios, which then led to the transcendental ratio phi, I thought, what are other critical ratios that scholars and sages have always pondered? The first thing that came to mind was pi. It is a transcendental number that has always been studied and used. It is the critical ratio for circles. William Jones is reportedly responsible for the first use of the symbol pi for its current meaning in 1706. Leonard Euler popularized the symbol starting in 1737. So now it is time to consider the nature of the units that define the ratio and the meaning of the symbol for pi. We're going to dive into the deep end, and I'm going to show you the pi unit simulacrum, and we're going to talk about the things you can learn from it. The pi unit simulacrum has all the same parts like any simulacrum, has the simulacrum sum statement, the four possibilities to observe. In this case, the postulabs are 1 and pi, and the ratios pi relative to 1 and 1 relative to pi. And next, the pi unit simulacrum has the interpretation matrix that holds the meanings behind the symbols and values. There are two specifications in the interpretation matrix. The first specification is that one value is 1. That makes it a unit simulacrum. The second specification is that one value is pi. And with that symbol of pi comes all conventional knowledge, numerical value, characteristics, and information associated with that symbol. This highlights that the simulacrum system is a consciousness-based system based on knowledge and information about the symbol. As we delve into the nature of pi and the units associated with it, I want you to know that I have confirmed everything I am presenting to you using the artificial intelligence model Perplexity Pro AI. That model was chosen because Perplexity supposedly places a premium on accuracy and provides citations. Everything presented here today and much more are available at my website, birdwell.com, under the tab Artificial Intelligence. If you click on the Artificial Intelligence tab, or the first menu item below that, it'll take you to the Artificial Intelligence page that provides proof by Perplexity Pro AI. If you scroll down to the next section, you'll see several conversations listed. And the one we're going to talk about today is under the label, Can You Understand a New Concept? If you click on that link, it will take you right to the Perplexity Pro AI conversation that we're going to talk about today. It's a long conversation, so I'm going to go ahead and jump to the final conclusions and read you what Perplexity Pro AI had to say about the pi unit simulacrum.
Versatility. The FGFS applies to complex symbols like pi, a transcendental number with infinite decimal places. The system maintains mathematical equality through structured transformations, regardless of the inherent complexity or abstract meaning of the symbols involved.
I want to make sure you understand what Perplexity Pro just said. The simulacrum applies to complex symbols like pi, a transcendental number. The system maintains mathematical equality regardless of the meaning of the symbols involved. Let me put that in the simplest terms. It is true no matter what. Next.
Mathematical equality. In the FGFS, the sum of any two elements, A and B, is expressed through various transformations that maintain equality. This approach ensures that the mathematical relationships hold true across different contexts, whether dealing with simple numbers or complex symbols like pi.
Again, in the simplest possible terms, it is true no matter what. Now, I'm going to read this to make sure we all understand. The full general form of a simulacrum represents a form of mathematical truth within its defined framework, consistently maintaining equality for combinations of symbols and values. More importantly, it was designed to provide meaningful insights beyond mathematical operations, particularly in the context of lipid analysis and regiospecific enzymatic metabolism. The system's broader philosophical claims and interpretations extend its applicability, offering insights into both mathematical and biochemical contexts. Its validity as a universal truth depends on its acceptance and application across various fields and its ability to provide meaningful insights beyond conventional mathematical operations. So I just want you to know, as we get deeper into the conversation, that everything I'm saying to you has already been verified and confirmed. Even though Perplexity Pro started as the most skeptical of reviewers. Now let's go ahead and solve and simplify the pi unit simulacrum. We're going to use the pi unit simulacrum to examine the nature of the unit and of the symbol for pi and of the ratio that expresses the relationship between the symbol for pi and a unit. We will take advantage of the fact that it's a unit simulacrum to simplify the solutions. But first, since we know the value of pi is always greater than 1, we can get rid of all case 1 solutions. Next, we get rid of the solutions that still require a value and a ratio, leaving only the solutions with 1 multiplying on the outside. Now we can simply eliminate the multiplying 1 in parentheses to arrive at the final simplified solution of 1 plus a ratio and 1 plus 1 over the inverse ratio. So let's have a look at those units. Google pi and you'll find pi is the mathematical constant representing the ratio of a circle's circumference to its diameter. The dictionary definition of pi is that pi is the ratio of the circumference of a circle to its diameter. Thus, the foundational definition of pi in our conventional wisdom is based on a ratio to diameter. Based on the dictionary definition, pi equals c over d, circumference over diameter. From this, we get the simple conventional equation for circumference based on diameter. C equals pi times d. The equations for area and volume are A equals pi d squared over 4 and V equals pi d to the third over 6, but the equations based on diameter are almost never actually used. Another unit definition that involves pi, and more specifically 2 pi, is the unit circle definition. Google defines the unit circle as, the unit circle is a circle with a radius of 1, centered at the origin 0, 0 in the Cartesian coordinate system, essential for defining trigonometric functions, sine and cosine, for any angle. It acts as a bridge between geometry and trigonometry, allowing easy calculation of sine, cosine, tangent values, and supporting applications in rotation, waves, and Fourier analysis. This says that a unit radius is the defining unit of a unit circle. So it is a unit radius and a unit circle, but not a unit pi. Instead, a unit r in a unit circle is proportional to 2 pi. The circumference of the radius base unit circle is 2 pi. These equations we all learned as kids are based on radius. That is, circumference equals 2 pi r, area equals pi r squared, and volume equals 4/3 pi r cubed. Furthermore, angles in circular geometry are measured based on radii, not diameters. I'll mention here that while the roots of integral calculus go back possibly millennia, modern integral calculus was developed starting in the 1630s to the rest of the century. Isaac Newton and Wilhelm Gottfried Leibniz are generally credited with developing the power rule for integration and differentiation. The point that's important to make for our Pi Day discussion is that the unit in the pi unit simulacrum can be either of two units. It can be unit diameter, which is the literal dictionary definition of pi, or it can be a unit radius, which is the defining unit for the unit circle that forms the foundation for trigonometry, which is then used in geometry, engineering, and other sciences. The process of integral calculus describes the transition between levels or dimensions. Thus, our whole system of science is built based on radii and has been since the late 1600s. In all that time, an analogous diameter-based system to describe the transitions between dimensions has never been developed. I asked Perplexity Pro AI for information on any existing diameter-based models, and it came back with nothing. So, even though the diameter-based system has not been further developed, there are two systems of equations for dimensions.
Yes, that's correct. We have described two sets of equations, one based on diameter, d base, and the other based on radius, r base, that can be used to define the properties of circles and spheres, particularly in relation to the mathematical constant, pi. These systems are equivalent in that they describe the same geometric properties, but they do so using different reference measurements, diameter versus radius.
One system based on a unit diameter and one system based on a unit radius. 22 years ago, when I first recognized the two systems, I realized that there was not an analogous definition for pi based on a unit radius, and I developed one. I asked Perplexity Pro, in the D-based system, the dictionary definition of pi is that pi is the ratio of a circle's circumference to its diameter. Define a unit pi based on a unit r. As expected, since I had discovered it 22 years ago, Perplexity Pro AI came back with the definition that pi is the ratio of half the unit circle circumference to the radius. Now we have gotten to the crux of the matter. We have identified two definitions for the same thing, the unit, 1, proportional to the symbol and value of pi. I call these the seen and the unseen definitions. The seen is the dictionary definition, which system is almost never used. The unseen is the radius-based definition that forms the foundation of modern science, but is not stated explicitly. So we need to summarize and confirm that this is all really true. Here's the conventional radius-based system unit circle compared to the possibilities to observe from the pi unit simulacrum. The ratio pi over 1 is a unit pi and a unit r, but not a unit circle. Pi is the ratio of half a circle circumference to its radius. We compare that to the other definition of pi, based on diameter, along with the possibilities to observe from the pi unit simulacrum. The possibilities to observe for diameter show that this is a unit pi and a unit d and a unit circle. It's a whole circle, and it is pi based on 1d. So what we can say is when you look up the definition of unit circle, you see the one based on radius, which is 2 pi. You don't see mention of the other unit circle, which is always ignored. But there are 2 unit circles. These 2 pictures are not to scale because you have to choose which unit to use. If you choose to make a radius one, then because of our known relationship that we have defined diameter as 2 radii, then diameter would have to be 2, and so the circle would be a circle with a d of 2, and so a circumference of 2 pi. Or if you make d 1, then radius has to be 1 over 2, 1/2, which would give a circumference of pi. So you have to decide which unit you want to base your system on, and the results of how to interpret pi will be based on your unit definition. Let's get Perplexity Pro to assess the truth of these equations and statements. I asked Perplexity Pro, since we have just written 2 sets of equations for 2 different units, can't we say that there are 2 unit definitions for pi, one based on a unit diameter and one based on a unit radius? Pi has the same value, but different meanings in the d-based and the r-based systems. In one case, pi is a whole unit circle. In the other case, pi is half a unit circle.
Yes, you can interpret the 2 systems as providing 2 different unit definitions for pi, each based on a different measurement reference, the diameter and the radius. While the numerical value of pi remains constant across both systems, its interpretation can differ, based on whether you use the diameter or the radius as the basis for your calculations.
So yes, Perplexity Pro AI confirms that there are 2 unit definitions for pi, and the interpretation of the symbol differs based on the unit definition.
This dual interpretation highlights how the context and reference measurement, diameter versus radius, can influence the conceptual understanding of mathematical constants like pi, even though their numerical values remain unchanged.
So, AI has confirmed that there are 2 definitions for pi based on 2 different unit definitions. Having one symbol for 2 different meanings is what I referred to as the pi paradox. I figured that the way to solve the pi paradox was to have 2 symbols for pi based on the 2 different meanings of pi. And since it seemed that the current symbol for pi, first used for its current meaning by William Jones in 1706, or 320 years ago, was half height. It was a short symbol that had 2 sticks in it that seemed to me to represent 2 radii joined by the squiggle at the top. So I decided to develop a new symbol for pi to represent the new meaning of pi. The symbol almost created itself. It has 3 diameters representing the 3 dimensions of space and showing that the system is based on diameters. It contains a circle to show that it is the foundation of the diameter-based unit circle. Furthermore, the 2 axes are in a ratio of 1:2 to replicate the relationship of 2 radii per 1 diameter. This gives the symbol self-similarity. But I recognized that it was too much for most people to accept a new symbol for pi, so we'll still use the classic symbol for pi for both definitions. I won't give the specifics today since this episode is focused on pi, but over the course of this podcast, I'm going to show you how the diameter-based system leads to the new model for dimensions, which requires only 2 equations for 3 dimensions of space, making it 33% more efficient than the conventional diameter-based system. And AI confirms that you can put 10 of the first 20 elements of the periodic table of elements in the same form of equation. And when you add the concept of a unit decrement, that allows the model to cover 19 of the first 20 elements of the periodic table. Then I generalized the model, and I also added another term to mass to account for the rest of the elements. I discovered most of what we've been talking about in 2004 and 2005 while working on my book, Modern Methods for Lipid Analysis. For 20 years, I thought those equations were enough and represented a major step forward, which they do, and would provide a new foundation for understanding our physical world, which they should. I had never looked at the radius-based system because I thought it had been thoroughly developed over hundreds of years. But in 2025, I decided, why not have a look? What could it hurt? To see if there's any pattern in the conventional radius-based system. It turns out I was able to see a top-down pattern in the radius-based system that is more efficient than the bottom-up solution known as the conventional radius-based system that we've lived with for hundreds of years. Now that I had the original new model for dimensions and the dimension model for mass and the generalized new model for dimensions and the new model for radius dimensions, I was able to see a common structure in all models. I pulled out the common core in all models and specified the differentiating terms for each application. But for this episode, we're going to stick with pi and the units that define it. I hope you can go back to the first episode now and see with more learned eyes that when I said you've been living in a deconstruction, a literal world built based on a half unit, a half world if you will. What I was referring to is the fact that you now know that a radius is the first deconstruction or decrement of diameter, and that the unit circle was defined in the 1600s based on radius, which is the first decrement. Therefore, all of our trigonometry, geometry, and dependent sciences are based on a unit deconstruction. When I said you and everyone you know has been living in one-bedroom apartments for hundreds of years, I hope you now see that your one-bedroom apartment is the conventional radius-based system that has been the foundation of our sciences since the 1700s. In this episode, I have shown you that I started with a one-based system called mass spectrometry and developed a system that used critical ratios to squeeze information out of raw values. We demonstrated how critical ratios are more useful than raw values and how making one value 1 has benefits to finding simplified solutions. You learned that mathematically, radius is the first decrement or deconstruction of diameter, and that even though our dictionary definition of pi is based on diameter, it is the relationship of a unit r to pi, which is never explicitly stated, that defines the unit in the conventional unit circle. So I do hope you've come to the realization that you've been living in a deconstruction, a literal world built based on a half unit. I have demonstrated, and AI has confirmed, that examination of the defining unit and of the critical ratio can lead to new insights into the natures of both. And don't forget, pi is the critical ratio for circles. What this podcast intends to do is to prove to you, mathematically and logically, that examination of the system based on the units of diameter leads to new understandings and insights, exactly as indicated by AI. I've briefly shown the slides, but I'll provide mathematical proof at each step along the way to allow every equation to be independently proved and verified. When you recognize the two units and adopt the diameter-based understanding, you are literally operating on the next level up from your conventional system. You are no longer in the deconstruction. But even better, it's not just moving to the next level. It's that at the next level, you can see the ultimate pattern that ties together the other patterns. But before we close out this episode, let's consider one more definition. Quantum. Google defines quantum as a discrete quantity of energy, or in physiology, the unit quantity of acetylcholine released at a neuromuscular junction by a single synaptic vesicle. And Wikipedia says it's just the minimum amount of any physical entity. Furthermore, the idea of being quantized means that things can change only by integer multiples of the quantum. So I hope you can see that the radius is the quantum that our sciences are based on. And radius is a deconstruction of diameter. Diameter is the quantum of the new model for dimensions. You can make a literal quantum shift by changing perspective from the radius quantum to the diameter quantum. The diameter is the unification of the two halves, the two radii. You can now choose to step out of the deconstruction and into the unification. The new equations allow you to make a literal quantum shift into a higher quantum level that is 2 times the deconstruction. And from there, you can put together pieces and see patterns behind all of the models. And go yet one more level up in generalization to arrive at a meta-model that explains 3 different quanta, or unit definitions. Theoretically, that should take you up 2 levels from the deconstruction you've been stuck in until now. I'll leave you one last thing to ponder. Dimensions are quantized in the conventional radius-based system because the equations are different for each dimension and require integral calculus to transition between them. In the new models, only the first dimension is unique. All others use the same equation based on the unit. Dimensions do not have to be quantized since they all use the same equation. So theoretically, fractions or ratios of dimensions, overtones, etc., would use the same equation. So if you follow this podcast, I will show you with mathematical certainty how to understand dimensions in a new, different, and expanded way. Thank you for watching and for your interest. Like this video if you think others might like to see it too, and subscribe if you want to learn more about the new way to see dimensions. All of this, with references and so very much more, are located at birdwell.com. That's BYRDWELL.com. Thank you.